Welcome back to my channel, everyone. Sweet Tips here. What I have here is some carat gold that we're going to refine. Mrs. Sweet Tips went out and found all of this stuff. This is available to anyone. Got to get up early, and you've got to get there first. If you don't, the other pickers will get there ahead of you, and they will get the material first. You got to know what to look for, and you got to know where to look. And Mrs. Sweet Tips has become an expert, and that's where she gets all this material that I get to refine. Alright, we had one guy that I bought this stuff from. These are his diamond rings, and he asked for the diamonds back. So we're going to try to get them out of here for him. The best way to do this is to just grab a couple pair of pliers like this and just twist until the diamonds come out. So we'll just have to wiggle this back and forth until we get these out of here. Not easy. Pour them out of there. Let's get them in a bag for him. Let's move our scale over here. And I've got a melt dish. And we'll put our melt dish up here on the scale. Zero the scale. I'm going to pour the 14K material in here now. 14K, 185.4 grams. Zero it back out. Here's our 10K stuff. And that amounts to 59.6. Let's zero that back out. Here's our 18K scrap. And what we have here now is 12.6 grams of 18K. Here's all of our carat scrap. I'm going to take this out, put it on the melt table, and get ready to inquart this gold with silver. This is a rather large batch of carat scrap, so I've set up the wet board so we can pour smaller granules of molten metal. Now let's go ahead and get this up here and get this melt started. I've calculated that I need 296 grams of sterling silver to properly inquart gold. I've got 296.4 up here on the scale. So we'll take this out now and use it to inquart the karat gold now that we've got it melted. Here we're adding sterling silver to the karat gold in the melt dish. We're trying to create an alloy that is 25% gold and 75% silver and base metals. And the reason we're doing this is to enable the nitric acid, boiling nitric acid treatments in the next step to penetrate into each piece of inquarted gold. And by lowering the gold concentration in that alloy down to 25%, the nitric will be able to reach down to the core of each little piece of inquarted gold and completely remove all the silver and all the base metals. If we fail to inquart the gold like this, nothing would happen when we put the pieces of karat gold into the boiling nitric acid. It would just sit there and the nitric acid would not be able to penetrate. The high gold content would shield the base metals and silver that's in the alloy from the action of the nitric acid. So by adding this additional silver, we're reducing the gold content, and that enables the nitric acid to penetrate to the core of each piece. And when we're done with these nitric acid boils in the next step, the gold that we get from that reaction will be very high purity gold, very close to 3/9 fine, just like it is. That's how effective inquartation and parting with nitric boils is. Now that I have the sterling silver incorporated into the karat gold in that melt dish, I'm using a graphite rod to stir the molten metal and make a consistent alloy. Now we're going to pour the molten metal onto that wet board set up. I've got water spraying on that board. And what this will do is it'll cause the molten metal to spatter and form smaller granules than if we just poured it straight into the water without the wet board there. And this reduces the size of the pieces of inquarted gold and allows the nitric acid to penetrate each piece more efficiently because they're smaller. The pieces of gold look like they've adhered together, but they're adhered loosely and they'll fall apart when we put those in the reaction beaker with the boiling nitric acid. got an estimated yield here of 142.2 grams of pure gold from all of this carat scrap. I've got all the tap water rinsed off of my inquarted gold, and I gotta be honest with you, this 6K gold has got a beautiful color to it. And now that we've reduced the concentration of gold in this alloy, we'll be able to use nitric acid boils to remove all of the silver that we added, plus all of the silver that was already in the carat scrap, and all of the base metals. Add the nitric here. We're going to put this up on the heat now and let this boil away. This will be nitric acid boil number 1. All of my silver jars are full of silver nitrate solution from previous gold refining. So now what we need to do is go ahead and make some room in here. We're going to filter this solution. What we'll do is filter this solution, and then I'll recover the silver out of the filtered solution down here, add it to our cement silver bucket that's full of copper, cement the silver out of this silver nitrate solution, and then gather it up and collect it so we can run it through the silver cell. Nitric boil number 1 is complete. We can tell by the lack of fume production in our beaker. I'm going to pour off this first nitric boil. Give it a quick rinse. Now we'll add some water. Put it back up on the heat. I'm going to add some nitric acid now. Equal amount, and this will be nitric acid boil number 2. Nitric boil number 2 is complete. Pour this off into our silver jar. And we're going to give it rinse with distilled water. I'm going to add distilled water. And now we're going to put some nitric in here. Equal amount. And this will be nitric boil number 3. Here's a look at the silver cell. We're doing a time lapse of the cell. Started this on Monday night, and today is Friday, so we've got about 4 days worth of time lapse down inside the silver cell. And when we get that complete, we're going to try to go for a full 10 days or so, and then when we get that complete, we'll publish a video of the time lapse growth in the electrolytic silver cell. We've still got some fume production, but I believe that this nitric boil has gone as far as it can go. Pour it off into our silver jar. I'll give this a quick rinse. Now we're going to add some more water to this. The gold is starting to look pretty good. Set it up on the heat and put in some more nitric. And this will be nitric acid boil number 4. Nitric boil number 4 is complete. You'll notice that there was no fumes in there, but there's still active nitric in here. We should get a fairly decent reaction when we hit this silver in this silver jar. And the reason that the fumes stopped in our reaction beaker here is because the nitric has become less potent by reacting with the silver that's in here. And so the reaction of it penetrating to the core to all those pieces of gold in here, that action has ceased and it can no longer penetrate. So what we got to do is add some more acid and get some more high potency acid in there and continue our nitric boils. I'm going to add some water. I will add some more nitric acid. And this will be nitric acid boil number 5. Nitric boil number 5 is done. Pour this off into our silver jar. Gold is looking really good now. See, that's a nice brown color. Alright, let's add some more distilled water. A little more nitric acid. This will be nitric boil number 6. This has been on boiling now for about 45 minutes or so. And if you look, we've still got just a little bit of color going on in there. So I'm going to pour this acid off. This will still be good acid that we can use to dissolve silver and base metals. Alright, here's what our gold looks like inside the beaker. It's looking fantastic. I'm going to give this a rinse with some distilled water. And pour the rinse off into our silver jar back here. Now we're going to add a little bit more distilled water. Now some more nitric acid in here. And give this one more nitric boil. The more time we spend here removing the silver and the base metals, the fewer problems we'll have when we do the refining with aqua regia. Alrighty, this 7th nitric boil has done the trick. Our solution is clear and colorless now. And if we've got all the blue color pulled out of there with these nitric oils, and it's pretty safe to conclude that we've got all the silver out of here too. I'm going to save this nitric acid. And here's a look at the gold in there. It looks really, really good. We've got this gold cleaned up really good. I think what we'll do now is add some water, just distilled water. I'm going to put it back up on the heat. And let's boil this in some distilled water just for a few minutes. It's been on boiling in distilled water for about a half an hour now. We're going to pour off this distilled water boil into the silver jar. You've heard me say it 100 times that at this point the gold in that beaker is very close to 3/9 fine, just like it is. And so we're going to do something a little different today. Instead of refining the inquarted gold that's had the silver and base metals removed with hot dilute nitric acid boils, instead of refining it in aqua regia, I'm going to add it directly to a melt dish. We're going to get all that gold down into the melt dish, and we're going to melt it up into a bar and take a look at it. See just exactly what it looks like at this point. Now that melt dish it's not a clean melt dish, it's been used, but it's only had pure gold melted in it. So we don't run the risk of contamination with other metals. It's just had pure gold melted in it up to this point. Now let's take it over here to the melt table. We're going to put some flameage on it and melt us a bar. Take a look at it. right, here's our bar of pure gold. You can tell a lot about the purity of gold by how the final bar looks. You can see this thing's got some obvious contamination on it. But for just inquarting with silver, and then pulling everything back out with the nitric boils, this is high purity gold, probably 995, maybe a little better, I don't know. I'd have to have it analyzed. Let's see what we got. We were expecting 142.2 grams. We got 137.3 grams. And that would be 4.4 troy ounces of pure gold. So this is good enough to be sent into the big refiner, no problem. All right. I'd like to wish everybody a good day. Thank you for watching, and that'll conclude the video.